You are standing in a room that has no air conditioner, no fan running, no electricity powering anything on the wall, and it is 7 degrees cooler than the air outside. $5. One bag, 15 minutes of setup. That is what you are about to learn. There is a material so porous that a single gram of it contains the surface area of a small apartment over 1,000 square feet, folded inside a piece the size of your thumbnail. The Amish families I visited in Holmes County, Ohio, exposed me to this 4 summers ago. They were not using it for cooling, they were using it for everything. But when I felt the air inside a barn in the middle of August and it hit me like walking into a cellar, I knew something was different. I spent 20 minutes trying to understand what I was feeling before Jacob, that is not his real name, but he would not want me using it, pointed to a shallow wooden tray sitting on the floor near the vent opening. Dark granules. Wet. That was it. Now, before I show you how to build this yourself, in 15 minutes, I need to tell you about a document I found while researching the history behind this technique. It traces back to a city in Persia that has been inhabited for over 7,000 years, a city where 700 of these cooling structures still stand today, some of them from the 14th century. And in 1798, when Napoleon's army arrived in Egypt, his artists documented the exact same system in detailed illustrations because they considered it one of the greatest engineering achievements they had ever seen. That history matters, because what I am about to show you works in any home you already own, not just new construction, and by the end of this video, you will understand exactly why no one ever told you about it. Let me start with the question that changed everything for me. Why does the air inside an Amish home feel different? Not just cooler, different. There is a quality to it that is hard to describe until you experience it. The air feels clean, it feels calm, and it is noticeably cooler than anything you would expect from a house with no mechanical system running. The answer is a material called activated charcoal. Not the briquettes you throw on a grill. Those are a completely different product and they will not work. Activated charcoal is carbon that has been processed at extremely high temperatures to open up millions of microscopic pores inside its structure. Those pores are what make it extraordinary. 1 gram of activated charcoal has an internal surface area of between 500 and 1,500 square meters. Think about that. A piece you can hold between 2 fingers has more surface area inside it than the floor plan of a decent-sized house. When you saturate those pores with water and then expose the wet charcoal to warm air, something remarkable happens. The water evaporates, and every single gram of water that evaporates absorbs 539 calories of thermal energy from the surrounding air. That heat does not go somewhere else in the room. It disappears from the air entirely. The air comes out the other side, cooler. No motor, no refrigerant, no compressor, no electricity. It is the exact same mechanism your body uses when you sweat. Your skin gets wet, the air evaporates that moisture, and the evaporation pulls heat away from your skin. That is why a breeze feels cool on a hot day when you are perspiring. Activated charcoal does the same thing, except it does it continuously, and it does it with a surface area thousands of times larger than your skin. This is not my opinion. This is peer-reviewed science published in journals you can look up tonight. In 2022, the Journal of Engineering and Applied Science documented an experiment using activated charcoal combined with natural loofah fiber as a cooling pad. They started with an ambient temperature of 95 degrees Fahrenheit. The air that passed through the charcoal system came out at 75 degrees, a 20-degree drop, no electricity. In 2018, researchers named Rono and colleagues published results in the Journal of Post-Harvest Technology showing a consistent drop of over 16 degrees Fahrenheit using a charcoal evaporative system with humidity rising 36%, which tells you exactly how the physics work. The water leaves the charcoal, enters the air as vapor, and in doing so, steals heat from that air. But here is the part they do not put on the evening news. This is not a new discovery. This is not some breakthrough from a Silicon Valley startup. This is 3,000 years old, and the people who perfected it built an entire city around it. The city is called Yazd. It sits in the middle of the Iranian desert, where summer temperatures regularly exceed 104 degrees Fahrenheit. People hear that and think no one could live there comfortably without modern technology. But Yazd has been continuously inhabited for over 7,000 years, making it one of the oldest living cities on Earth. 7,000 years. That is 5,000 years before Willis Carrier was born. And the people of Yazd were not just surviving the heat, they were thriving in it. The city has 700 documented structures called bad gears, wind catchers, tall towers, some of them rising over 100 feet into the air, designed to capture wind from any direction and force it downward into the building below. The tallest badger in the world still stands in the Dalatabad Garden in Yazd, over 109 feet tall. It still works today. Nobody maintains it with parts from a factory. Nobody calls a repairman. But the badger was only half the system. At the base of those towers, the Persians placed wet charcoal and water-saturated clay jars. The air was forced down through the tower, passed across those wet materials, lost its heat through evaporation, and entered the living space cool and clean. The tower captured the energy. The charcoal and clay did the cooling. Two components, both free, both requiring nothing but wind and water to operate. Researchers from the University of New South Wales measured the performance. Buildings in Yazd equipped with bad gears maintained indoor temperatures 8 to 12 degrees Celsius, cooler than the outside air during peak heat hours. That is 14 to 21 degrees Fahrenheit in a desert, with no electricity, with no energy source other than wind and water. And here is the detail that still keeps me up at night. The Persians did not just cool their homes with this system, they refrigerated food. Underground water reservoirs called A-B Anbars were connected to Badger towers. Researchers from Weber State University confirmed that the combination of evaporative cooling and underground thermal mass could bring water temperatures close to freezing in the middle of a desert summer. Refrigeration 1,000 years before Christ. No compressor, no Freon, no monthly bill. Ice cold water in a place where the ground temperature reaches 140 degrees. And Persia was not the only civilization that figured this out. In medieval Cairo, they called the same structures Malkaf. They were built into mosques, caravansaries, and palaces across the Arab world. The design was so effective that when Napoleon's army arrived in Egypt in 1798, his expedition artists, the same team that documented the Rosetta Stone, made detailed illustrations of the Malkaf systems. They were astonished. They considered these cooling towers to be one of the most remarkable engineering achievements they encountered in all of Egypt. French military engineers, trained in the most advanced European institutions of the time, looked at a system that required no fuel, no machinery, and no maintenance, and could not believe what they were seeing, and then the world forgot about it. Now let me show you the math on what forgetting has cost you. The average American household spends between $150 and $400 per year on electricity just for cooling. That is just the running cost. A new central air conditioning installation costs between $5,000 and $15,000. The average unit lasts 15 years before it needs to be replaced, and that is with regular maintenance, filter changes, and at least one major repair during its lifetime. Add it all up, and over 15 years, you are paying somewhere between $7,000 and $21,000 to cool your home. $7,000 on the low end. Before I show you exactly how to build this in 15 minutes, everything I have documented across this channel is in one place. The stove, the tunnel, the water, the fuel. Now this. It is called the Amish home system. Every system, every material, every exact step. Link is in the description. But stay here. Because what the Persians paired with the charcoal to double the cooling effect is the part nobody has ever published online. A bag of activated charcoal costs $5 to $8. A tray costs nothing, you already have one. Water from your tap costs nothing. Even if you replace the charcoal every season and buy a new bag each May, your total cost over 15 years is $50 to $80. That is not a rounding error. That is a fundamentally different relationship with how you live in your home. So what happened? How did 3,000 years of proven functional free cooling technology disappear from the world? You would think that something this effective, this simple, this well documented across multiple civilizations would be common knowledge. You would think they would teach it in schools. You would think builders would offer it as an option. You would think anyone in the home improvement industry would mention it. Nobody does. And there is a reason. I will tell you exactly what happened. His name was Willis Carrier. On July 17th, 1902, a 25-year-old engineer fresh out of Cornell University installed the first modern air conditioning system in a printing plant in Brooklyn, New York. His goal had nothing to do with human comfort. He was not trying to cool a home. He was not thinking about families in Texas or retirees in Florida. He was trying to solve a humidity problem that was warping color printing paper. That was it, a printing problem, a paper problem, not a people problem. But Carrier saw something bigger. He saw that if you could control humidity, you could control temperature, and if you could control temperature, you could sell that control to everyone who had ever been uncomfortable in July. In 1915, he founded the Carrier Corporation with $35,000 in startup capital. The first residential air conditioning unit hit the market in 1928. It was expensive, it was loud, it was clunky. Most families could not afford it and did not see the need because most homes in America were still built with passive cooling features, porches that shaded walls, high ceilings that let heat rise, transom windows above doors that created airflow through the house, attic vents that pulled hot air up and out. The house itself was the cooling system, but the real explosion did not happen until the 1950s. Post-war Americans had money, manufacturers had the factory capacity, and suburbs were spreading across the country at a pace nobody had ever seen. Developers needed to build fast and build cheap. Passive cooling features, porches, thick walls, proper orientation, ventilated attics, all of that took time, took skill, and took space on the lot. An air conditioning unit took none of those things. You could build a simple box, slap a unit on the side, and call it comfortable. By the 1960s, air conditioning was no longer a luxury. It was becoming standard. And that is when the erasure began. Architects stopped designing for climate. Think about that. For thousands of years, every building on Earth was designed to work with its environment. Narrow alleyways that created shade, thick walls that absorbed heat during the day and released it at night. Courtyards that created natural ventilation, windows positioned to capture cross breezes, roofs angled to deflect sun. All of that knowledge accumulated over millennia was abandoned in a single generation. Because air conditioning existed, architects started designing glass boxes with sun-facing facades, deep open floor plans with no natural ventilation, and flat dark roofs that absorbed maximum heat. These buildings were uninhabitable without mechanical cooling. They were designed to be uninhabitable without it. And that was not an accident. That was a business model. In the Persian Gulf, the very birthplace of the Badger, 20th century leaders hired European architects to build modern cities. Those architects imported designs that worked beautifully in the cool climates of Belgium and France. In Kuwait and Abu Dhabi, those same designs were ovens. They required massive industrial air conditioning just to be livable. And the ancient Badger towers that had kept those cities cool for 3,000 years were literally demolished along with the old buildings to make way for the new glass ones. The numbers tell the rest of the story. The global HVAC industry generates $130 billion every year. Let me say that again, because numbers that large stop meaning anything. $130 billion every single year. Residential air conditioning alone accounts for 12% of all electricity consumed in homes worldwide. That means for every dollar you pay on your electric bill, roughly 12 cents goes to cooling air that your house was designed to trap heat in the first place. You are paying to fix a problem that was engineered into your home on purpose. And it gets worse. The HFC refrigerants used in modern air conditioners have a global warming potential 1,000 times greater than carbon dioxide. In 2022, The electricity used for cooling produced 1 billion metric tons of CO2, the equivalent of 238 million gasoline cars driven for a full year. The machines we use to cool our homes are heating the planet, which makes our homes hotter, which makes us use the machines more. That is not an accident. That is a business cycle that feeds itself. The same year those numbers were published, the Badgers of Yazd were still functioning, the same ones that have been standing for 700 years. Nobody paid a utility bill for them. Nobody replaced a compressor. Nobody called a technician. 4 companies control 90% of the residential HVAC market in the United States: Carrier, Trane, Lennox, York. They did not ban passive cooling. They did something more effective. They made it unnecessary, and then they let it be forgotten. They funded the research. They influenced the building standards. They shaped the curriculum in architecture schools. And within one generation, thousands of years of cooling knowledge simply vanished from mainstream awareness. Now, if you already own a house and you are thinking this only applies to people building from scratch, stay with me, because this next part is specifically for you. I know what you are thinking. You are thinking your house was built in 1972 or 1985, and it is what it is. You cannot add a wind tower. You cannot redesign the floor plan. You are not tearing out walls. I get it. I live in a house built in 1978 myself, but that is exactly why this works. Because you are not changing the house. You are changing what happens to the air before it reaches you. Here is what you need. 1 bag of activated charcoal, the kind sold for aquarium filters. You can find it at any pet store, PetSmart, Petco, or Amazon. You want loose granules, not the kind sealed inside a filter cartridge. A 500-gram bag costs between $5 and $8. That is less than a fast food lunch. You also need a shallow tray, a baking sheet, a plastic container, a wooden box lined with a trash bag, whatever you already have in your kitchen, and water from the tap. That is it. That is the entire system. No hardware store trip, no special order, no tools. Spread the charcoal in a layer about 2 inches deep across the tray. Pour water over the granules until they are completely saturated. Let them absorb for 5 minutes. Then drain off any standing water. You want the charcoal soaked like a sponge, not sitting in a puddle. The whole process takes 15 minutes, and most of that is waiting for the charcoal to drink up the water. Now here's the part that makes the difference between this working and this being a waste of your time. Placement. This is where most people get it wrong. Do not put the tray in the center of the room. Do not put it on a table next to a lamp. Do not put it next to your chair. Put it on the floor, directly beside the window or door where air enters the room. Every bit of air that flows into that room should pass over the surface of that wet charcoal before it reaches you. That positioning is the difference between 0 degrees of cooling and 7 degrees of cooling. The Persians understood this 3,000 years ago. They did not put their cooling materials in the center of the room. They put them in the path of the airflow at the base of the tower where the air entered. The charcoal is not air conditioning, it is an air treatment station. It works like a gate. The air has to pass through it. If you put it somewhere the air does not flow, you are cooling a 6-inch radius around the tray and nothing else. Put it in the airflow path and the entire room benefits. Maintenance could not be simpler. Every morning, pour 1 cup of water over the charcoal, 30 seconds, once a month. Take the tray outside, spread the charcoal in direct sunlight for a full day. The ultraviolet light breaks down the compounds the charcoal has absorbed and resets it to full capacity. 1 bag lasts an entire summer season. If you want to replace it the next year, that is another $5. For a small bedroom, 1 tray is enough. For a larger living room, set up 2 or 3 trays at different air entry points. And if you have a workshop, a garage, a chicken coop, or a barn, build a simple wooden frame with wire mesh on both sides, fill it with charcoal, and mount it in the ventilation opening. Same principle, larger scale. Now let me be honest with you, because I respect your intelligence too much to exaggerate this. And honestly, the honesty is part of why this works as a message, because you have been lied to so many times by people selling you things that when someone tells you the real numbers, you actually trust the information more. The amount of cooling you get depends on where you live. Specifically, it depends on the humidity. In dry climates, West Texas, Arizona, New Mexico, the Great Plains, parts of Colorado and Utah, the temperature drop can be 13 to 18 degrees Fahrenheit. That is transformative. That is the difference between being miserable and being comfortable. In those climates, this system performs at a level that rivals a window AC unit. In humid climates, Ohio, the Great Lakes region, the Southeast, the Gulf Coast, the realistic drop is 4 to 7 degrees. The physics have not changed. But when the air already carries a lot of moisture, there is less room for evaporation, and less evaporation means less cooling. This is the same limitation that every evaporative cooler has, including the ones they sell at hardware stores for $200. The difference is that theirs requires electricity and costs 40 times more. But let me put 4 degrees in perspective for a moment. 4 degrees Fahrenheit in a bedroom in July is the difference between tossing and turning all night and actually sleeping. It is the difference between running your AC on high and running it on low or not at all. It is the difference between waking up drenched in sweat and waking up rested. And it costs you nothing after the first $5. Not 1 penny. Now here is something most people do not think about, and if you raise chickens or keep any kind of livestock, this part alone could be worth more to you than everything else I have said. Activated charcoal does not just cool air. When it is wet, it chemically absorbs ammonia, hydrogen sulfide, and volatile organic compounds. Those are the exact chemicals responsible for the smell in chicken coops, barns, dog kennels, and horse stalls during the hottest months. It does not mask the odor the way a candle or an air freshener spray does. It removes the molecules from the air entirely. The chemical bonds with the carbon surface and it is gone. And this matters beyond comfort and beyond smell. Heat stress in poultry begins at 86 degrees Fahrenheit. Above 100 degrees, it becomes fatal. If you have ever lost birds during a heat wave, you know exactly how fast it happens and how little you can do once it starts. A $7 system mounted in the ventilation opening of a coop that drops the temperature even 4 to 7 degrees is the difference between losing birds and keeping them alive. It is also the difference between eggs and no eggs, because heat-stressed hens stop laying long before they die. If you have ever had to deal with a coop full of panting birds in a July hot spell and felt helpless, you understand exactly what I am saying. This is not abstract. This is money. This is your flock. This is food on your table. But I promised you something at the beginning of this video. A technique I found buried in the research that almost nobody talks about, and I need to tell you about it now, because this is the part that changed how I think about cooling entirely. While I was going through the historical documentation on the Persian badger systems, and I spent weeks on this, going through journal articles, translated texts, and university archives, I came across a detail that researchers from the University of New South Wales had noted, but that never made it into any mainstream publication I could find. Not in any home improvement guide, not in any DIY channel, not in any government energy-saving pamphlet, nowhere. The Persians did not just use wet charcoal, they combined it with something else. They placed unglazed clay vessels, simple terracotta pots filled with water alongside the charcoal at the base of the wind tower. The terracotta is porous. Water slowly seeps through the walls of the pot and evaporates on the outer surface. That evaporation cools the pot, which cools the water inside, which cools the air around it. 2 evaporative systems working side by side, each amplifying the other. And this is what the researchers measured that genuinely stunned me. When wet charcoal was used alone, the cooling effect was significant, the numbers I already gave you. But when the charcoal was paired with a water-filled terracotta vessel placed directly beside